Hello, my geometry students. All right, the goal of today's video is just to see one of each type of questions that you're going to see appear on the test. So let's jump right in. So with number one, you are given similar triangles, and then they are just clarifying the lengths here with what's given. It says determine the length of AB. So similar triangles means corresponding sides are proportional. So AB, the first two letters there, should be to DE as AC, the first and last letter, are to DF, the first and last letter. So we can set up our proportion. So I can say like X is to 4, and then as X plus 2 is to X plus 6. And there's a lot of ways that proportion can look, but that's at least one way that'll do it. All right, let's cross multiply. We get X times X plus 6, and then 4 times X plus 2. Multiply by distributing through everything. So we get x squared plus 6x, 4x plus 8. And then when you have a squared and other x terms, get everything equal to 0 so that we can factor. So subtract the 4x over, subtract the 8 over. So I'm going to get x squared plus 2x minus 8. And then my goal here is what adds to 2 and multiplies to negative 8. So x and x, we're going to have plus 4 and minus 2 so that I get that positive 2. And then when I go to solve, I know those signs are going to flip. Make sure if x represents a side length, then I'm rejecting any negative answers. So the question says determine the length of AB, which AB is x all by itself. So AB should be equal to 2. There we go. All right, number 3 is the next one that I would like to look at together. 3, we've got triangle DEC similar to triangle ABC. If it helps, take a quick second and redraw the triangles so that you can see them as two separate similar triangles here. So then here's our ABC. So CD is 3, DA is 2. All right, so that makes this full side length 5. And then AB, the bottom is 10 here. And so find DE, well, that I can just call X. So now that I can see it as two separate triangles, I can say that DE, the first two letters here, are to AB here. So X is to 10. And then as CD is to AC. So CD is to AC. So this is usually where I would kind of bust out some colored pencils, but just using the different notations works as well. All right, when we cross multiply, we get 5x and then equals 30. Divide by 5, x comes out to be 6. And since I let DE equal x, that means DE equals 6 and done. All right, we're going to move on over. So moving on to page 39, here are all the questions where you've got an altitude drawn in a right triangle, which forces all those similar triangles here and therefore proportional parts. So the first one uses the cute little walk the dog. It's the idea of using the legs of the triangle on the left compared to the legs of the triangle on the right. So 5 is to x, and then as x is to 9. So the altitude is the mean proportional here. We get x squared and then equals 45. When you go to take the square root, since there's only one x squared term and no other x's, this breaks right back down into radical 9 times radical 5, the square root of 9 being 3, and then we keep that radical 5 here. Number 7 is the next one. Keep in mind, you can pause at any moment or rewind if needed. With this one here, the altitude is drawn but not labeled. So we're using the leg over here. So that means in this little triangle, we're doing leg to hypotenuse. So leg to hypotenuse. So x is to 8. And then as now look at the big triangle. So just I'll kind of draw right over it so you can see it. So that would be leg. And then the hypotenuse is the full length here, which is the x plus 12. So then we can say 8 is to x plus 12. So the leg is the mean proportional between those two pieces. All right, when we cross multiply, this is going to give me x times x plus 12. This will give me 64. You can distribute that right through and get x squared plus 12x. And then, of course, move that 64 on over by subtracting it over to the left-hand side. And then factor. If it's not, immediately obvious what your options are, go into your calculator. If there's anything in that y equals, you can get rid of it. And then into y1, you can do 64 divided by x. So let me type that in here. And then when you look at your table, you'll see all the factors that will give you 64. So 1 times 64, 2 times 32, 4 and 16, which I think that's what'll do it right there. So if we do x plus 16 and then x minus 4, that'll add to 16, multiply to negative 64. There we go. All right, when you go to solve, technically we set that equal and then subtract it over. We tend to skip showing that, but just as a reminder. And then we reject the negative because we can't have a negative side length there. All right, that is number 7. So we're going to move off of page 39. Let's head right on over. I'm going to go right past page 40 because those are the same type of questions until I get to page 41. And these ones are all talking about the ratio of the sides, perimeters, and areas of similar figures. So it says 2 similar polygons. It doesn't even tell you what type because it doesn't matter. So if the ratio of the sides, let's pretend, is 3 to 7, the ratio of the perimeters will be exactly the same thing. The ratio of the areas, since areas is units squared, is each of those things squared. So you can write it as 3 squared to 7 squared, or we could make it 9 to 49. That would be the ratio of the areas. The last part, don't be tricked by that. Angles is always 1 to 1. Right? Now let's put that to use. Number 12. Here you're given 2 similar triangles, RST and UVW, and you're given 1 side length here to 1 side length here. I like writing the ratio of the sides off to the side. And so you can write it as a fraction or using the colon like we just did. But 30 to 45. Just a little reminder on your calculator, you can do 30 divided by 45. Oops, just kidding. And then math frac. That's what I was looking for. So the ratio of the sides would be 2 to 3. That means the ratio of the perimeters will also be 2 to 3. The ratio of the areas will be 2 squared to 3 squared, or 4 to 9. All right, now when you go to set it up, just make sure you're paying attention to the order. So for the perimeters, smaller triangle to bigger triangle is 2 to 3. Smaller perimeter to the bigger perimeter would be 42, and then to P. You can simply cross multiply, so 2P, and then 3 times 42. That'll give us 126. And then divide by 2. That's going to give us 63. And the label should be feet. All right. For the areas, same thing. Just make sure you use the appropriate ratio. So you can write it as 2 squared over 3 squared, or 4 to 9 is what that's equivalent to. And then smaller triangle to bigger triangle. So 216, and then is to the area of the larger triangle. Cross multiply, we get 4A. 9 times 216, that'll give us 1,944 divided by 4. And we come out with 486. Now it's an area, so it's feet squared. And there we go. All right, moving on. We are going to hop right over page 42 to page 43. On page 43, we have some proofs. It's been a little bit, but we know that these proofs are nice and simple. Our goal is to be able to use angle-angle similarity. And this one has 2 pieces. They're clarifying they want you to prove these triangles similar and then be able to say those proportional parts. So it kind of covers everything in one proof, which is why I picked this one. So give yourself your columns, so your statements, your reasons, and then get that very first given in there. So ABCD is a parallelogram. Feel free to write it out or just draw a little parallelogram with a P in it. Okay, let's look at what we're working towards. So EFB, that's this triangle down here. We want to say that that's similar to triangle CFD. So CFD, this guy here. Okay. They're telling you parallelogram for a reason. So think about the name itself. Parallelogram inherently has opposite sides parallel. So the sides that I care about are the ones that are in the triangles themselves. So that would be DC and then AB. You can mention the other two sides, AD and CB, if you like, just to cover your bases. Parallel lines, though, here's where we get the angles that we're hoping for. So parallel lines. In this particular case, you can kind of see that Z shape pop out. We can use the Z here, or you can use kind of the backward Z. Either one would be fine. I'm going to make it easy and call it angles 1 and 2, but I'm going to get congruent, alternate, interior angles. And so over here, that's what I want to say is that angle 1 and angle 2 are congruent because parallel lines tell me we should have congruent alternate interiors. To get the second angle, you have a choice. You can use the other pair of alternate interiors, or you might be saying, I've got some vertical angles here. Let's take advantage of that. Again, I'm going to number my angles just to make it easier. So 3 and 4 are congruent because vertical angles implies congruent angles. There's one pair, there's the second pair. They're both inside the triangles we want. So we can say that triangle EFB is similar to triangle CFD by angle similarity. All right, that knocks off the first proof statement. You've got a second proof statement. We now want to say that DF is to BF, and then as CF is to EF. Well, those are parts of those triangles, so we don't have to say anything else in between these steps. We can go right from here to here and say that DF is to BF as CF is to EF. And then the reason for being able to say step 6. We should be able to say similar triangles implies had like a brain fart there, corresponding sides are proportional. I was going to say corresponding parts, but the angles really, we wouldn't say are proportional, they're equal. So we would say the sides specifically. So corresponding sides are proportional. Okay, did I leave anything else I wanted to look at with you? That was page 43. As we look at the left 44, you've got some multiple choice, 45, 46. Oh, there we go. Last ones I wanted to look at. So all the way to page 46. Back here, let's take a look at number 26. Here's the last question. If you look, it does not say it in the directions, but these two being congruent means this is a midpoint. And same argument over here, which makes this segment a mid segment. So there's a midpoint. And the rule for a mid segment is it's equal to half the length of the side it's parallel to. So 4n plus 5 should be equal to half of the length of 74. Since 74 is a nice even number, that makes it easy to work with. If we take 74 and chop it in half, it should be 37. And then we're just solving that little linear equation. So subtract 5, we get 4n equals 32. divide by 4, and n comes out to be 8. All right, that's the last one we're doing together. Thanks for watching, guys. See you soon in class to do some more review.